Hi, I'm here today to go over your 17.1 notes on using y equal ax squared plus k to model data. So just a quick blip. This is a whole lot of information on these first two blocks, and it's a lot just to set the scenario. But Jose here is going to kick a soccer ball. It's going to go up in the air, and then it's going to come back down. So it's going to make this shape, which implies that it's a parabola. And we're going to just enlarge in the chart right here and look at the chart. These are types of questions that you might see on the ACT, so we just wanted to make sure that we touched on this. If you are given a table of values, the way you tell whether or not it makes a quadratic, which means it has an x squared, is you compare the difference between the x values. So from here to here is a change of this. From here to here is a change of this. The differences of the x values have to be constant. And we call this the first difference because that's the first time we've done it. So first thing that has to happen is the first differences of the x values are the same every time. So that's checked off. Then we do the same thing with the y values. Now, they cannot be the same every time if this is quadratic, because if the x differences were constant and the y differences were constant, that would make a linear equation. So we know it's not linear because it goes back down like that. So then we look at the second differences. So now we're taking these and finding the difference from here to here, the difference from here to here, and so on. And when you look at these second differences, if they are very close to the same, that's how you know it is a quadratic. So one more time, from a table, the way you tell if the data represents a quadratic function, the first differences of the x's are the same. The second difference of the y's are nearly exactly the same. All right, that's just a free tidbit. Here's what we really want to talk about today. What a and k do to the parabola. So this a value has two different things. One, it tells you whether it opens up or down. If a is positive, the parabola opens upward. If a is negative, it opens downward. It also controls how wide or how narrow the parabola is. So it's kind of weird, but to get wider, it feels backward. The number in front of the x squared, which is the a, has to be a fraction between -1 and 1. So say 1/2, 1/3, 2/3. Anything that is smaller than 1 makes a wide parabola. Anything bigger than 1 makes a narrow parabola. We'll talk more about this on the backside. The k value, that controls the vertical shift. So this just literally moves the parabola up or down. So turn the page. You've got this equation, y equal x minus h squared, y equal x minus h squared, when h is positive and when h is negative. So I don't really know why they're asking it like this, but what they want you to realize is the number inside the parentheses with the x moves the graph left and right. Okay, so this is actually the x coordinate of the vertex. If h is positive, it would look like this. It would have the minus sign because remember, it works opposite from what the sign looks. So if h is positive, it would say minus h, and that would move the graph to the right. If h is negative, you would really write it like this. You wouldn't say minus a negative h. So you would say it's positive. That moves the graph to the left. Okay, that's kind of a confusing way that's written, but I think it'll make more sense when we talk about it here with the numbers. Okay, so here, looking at the numbers, this is a. A is negative. I know my parabola opens downward. A is a fraction. I know that makes it a little bit wider than a normal parabola. Inside the parentheses with the x, there's a -3. I know that that moves this parabola 3 units to the right. So instead of the vertex being here, see how it's moved over 3 to the right? And again, it works the opposite direction of this sign. This minus sign moves it to the right. If this had been a plus sign, it would move it to the left. This moves it up and down. So instead of it being here at 0, it's actually moved up 5 units. And this is my vertex, over 3 and up 5. Okay, so when you look at this one. You can see that A is positive, so it opens upward. A is 3, so it's a little more narrow than a regular parabola. It has a -2 in here, which means it has been moved over 2 to the right. And it has a -1, so it's moved down 1. And then finally this one. Again, A is positive, so it opens upward. It's a little more narrow than a standard parabola because this 2 is bigger than 1. This +4 moves this one left 4 units, so instead of being here, it's here at -4. This -3 moves it down 3. All right, using that information still. All these different parabolas, they want us to find the vertex. So remember, the vertex, the x value is what's in the parentheses with the x, opposite sign. The y value is the plain number, don't change the sign. So the constant without a sign change. This one has a vertex at +5, +1. This one has a vertex at opposite sign of what's in the parentheses, same sign as the constant that's added. This one has a vertex at 7, -6. Okay, so one more time. The number inside the parenthesis with the x gets the opposite sign. The number added or subtracted on the end does not get a sign change. Okay, but then when one of them are missing, it gets a little bit confusing. So when you look at this one, there is nothing added or subtracted on the end. They're never going to write the +0. You just have to know that this one is at +3, 0. This one has both parts, so it's not as tricky. This one's at -7, -4. This one is the one that seems to trick people most often. See how there's nothing inside the parentheses with the x? And again, they'll never write it like this, but it's the same thing as this. You just have to know that this 5 is the k value. And the reason I know it's the k value is because it is not inside the parentheses with the x. There are no parentheses, which tells me the x value of the vertex is 0. All right, I know this is a lot. Hang with me. Okay, so without actually graphing, describe the differences between the graph of each function to the graph of the parent quadratic function. So they want us to compare this to this, compare each of these to this. Then state the vertex. All right, so this one, y = x squared, you know that's just your standard parabola. The only difference here is it has a -1. So the difference is it opens down instead of up. And then they want to know the vertex. So remember how we talked about when it was missing pieces, how there's nothing inside a parenthesis with the x? That means 0. See how there's no constant added on to the end? That means 0 for the vertex. This one, so the A is still the understood 1, so no changes there as far as opening up or down or wider or more narrow. The only difference is this has this -2 inside the parentheses with the x, which tells me that my vertex is at 2, 0. So the difference between this and this one has moved 2 units to the right. Okay, but now this one has all kinds of stuff going on. So here's the first difference. It opens down because of the negative sign. The 1/4 makes it more narrow. Again, that feels backward. No, I did say that backward. Sorry. It does not make it more narrow. It makes it wider. Very sorry about that. The fractions make it wider. Okay. It has a +7, so I know that means it moved left 7. And it has a -3, so it's moved down 3. And my vertex would be at -7, -3. All right. Which of the following represents a parabola that opens the opposite direction of this one and has been shifted 1 unit left and up 4 units? Whew. All right, so a lot of stuff going on here. So the first thing I know is if it opens the opposite direction, it would have to be a +2. If it has been shifted 1 unit left, right now it's 3 units to the right. So if it backed up 1, it would be at 2 instead of 3. And up 4 units, right now it's at +5. So if it goes up 4 more, it's at 9. So it looks like this one. Whew, that was a lot. Okay, really use this right here. This is just a great help for you. This one, this letter in front of the parentheses tells you whether you've had a stretch or a shrink and which way it opens. This one moves it left and right, opposite sign. This one moves it up and down. All right, you are ready to roll.